I feel like at this point, pretty much everyone knows that hydroponics grows bigger, faster, and usually healthier plants than you're gonna find in soil. This isn't really news anymore. So in this video, I'm not gonna spout off a bunch of stats to try to convince anyone to switch to hydroponics. Instead, I want you to look at the science on a molecular level. So by the end of this video, you won't just know that hydroponics can work better, but you'll understand why it works better. To start though, we have to rewire the way that you think of hydroponics as a whole. See, where most people think of hydroponics as growing plants faster, it's actually better to think about hydroponics as just removing the bottlenecks that slow plant growth down. Hydroponics is gardening engineered, and it's engineered for one thing: access. So in this video, I want to ask two main questions, and I want you to think about these questions because the majority of people that I ask get them wrong. First question: what exactly do roots absorb? The second question, and even fewer people get this right, is do plants breathe in carbon dioxide and exhale oxygen, or do they breathe in oxygen and exhale carbon dioxide? Let's start with that first question. What exactly do roots absorb? When I ask this to most people, they say water, or dirt, or soil, or nutrients, or they'll start spouting off the individual nutrients like calcium, potassium, magnesium, nitrogen. But plants don't absorb nitrogen, potassium, calcium molecules as a whole. They can't. All plants, whether in hydroponics, soil, peat, cocoa coir, whatever your growth medium, plant roots absorb charged ions. So what the hell is a charged ion? To keep things simple, let's take a look at the simplest element in the universe, hydrogen, and turn it into a hydrogen ion. So here we have a hydrogen atom. Its atomic structure is one negatively charged electron orbiting one positively charged proton. You can think of these like opposite sides of a magnet. It's the balance between them that keeps the atom electrically neutral. So if you were to remove the electron, that balance would be lost, and the atom would now be missing a negative charge, and it would become positively charged. At that point, it's no longer just an atom, it's an ion. A negatively charged ion forms when an atom has extra electrons. So when roots absorb nutrients, they're not absorbing calcium or potassium as whole neutral atoms. They absorb charged ions, not calcium, but calcium 2 positive. Not potassium, but potassium positive. And there's a really good reason for that, because plants don't just run on water and sunlight, plants run on electricity. If you want to know more about exactly how the electrical system in plants work, then check out this video. But to simplify it for now, every cell behaves a little bit like a battery, and those batteries need ions to charge. The more available those ions are, the faster the battery charges. And just to get a little terminology out of the way, a positively charged ion is called a cation, and a negatively charged ion is called an anion. That becomes important when we talk about soil, because in soil, ions are not just unlocked and ready to use. Think about it like this. It's like when you go to the grocery store just to buy some razor blades, and you get there and they're all locked up in that cabinet that you have to go find the one of two people who are totally overworked in the grocery store to come and unlock for you just to get your razor blades. That's like the cation nutrient exchange. With plants, the nutrients would be the razor blades, the soil itself would be the lock, and the person who comes and unlocks it, well, that would be the hydrogen ion. Many of the nutrients in soil are held onto clay and organic matter surfaces through a process called cation exchange. Think about it like massive parking lots, and all of the spots are filled with different ions and molecules. For the plant to access those nutrients, it has to release hydrogen ions into the soil to swap place with them. That process takes energy from the plant, and that energy comes from ATP, which, as you'll learn in a moment, ATP is the secret sauce behind hydroponics' Big Mac of perfection. If we stick with the razor blade analogy, then soil is like driving to the store, finding the razor blades locked up, tracking down an employee and asking them to unlock them. Hydroponics is Amazon delivered by a drone. The second you place the order, it's there. No lock, no employee, no cation exchange delay, just a pool of nutrients already dissolved, ionized, and ready to move straight into the plant. It's simply a matter of efficiency. Okay, now let's answer the second question, and I'll be totally honest with you, it's rare that I meet somebody who actually gets this one right, and part of that's because it's kind of a trick question. See, most people know that plants breathe in carbon dioxide and then breathe out fresh oxygen, but what people don't realize is plants actually 24 hours a day are also breathing out carbon dioxide while they're breathing in oxygen to make ATP. Just not through their leaves, through their roots. This process is called respiration. Just like in animals, plants constantly respire using oxygen to produce ATP. But roots are where oxygen often becomes the bottleneck. And this is the second reason that hydroponics, or particularly aeroponics, can outperform soil. The first was ion availability, and the second is oxygen availability. But let's look more into the science. Roots absorb dissolved oxygen from the water surrounding them, and that oxygen fuels respiration in the root tips. That's where the plants are actively growing. Every molecule of nitrogen that gets pulled into the plant, every drop of water that travels up the stem, every new cell that forms in a leaf or fruit, it all traces back to ATP produced in the root tips. ATP is the fuel, oxygen is the ignition, and when respiration speeds up, ATP production increases. When ATP increases, growth follows. So how does hydroponics provide more oxygen? In many soils, particularly when they're wet or compacted, the oxygen levels drop dramatically. But a properly aerated hydroponic system can maintain much higher and much more stable oxygen availability. In aeroponics, roots can even experience oxygen levels close to atmospheric conditions. And the moment oxygen becomes limited, the engine sputters, the entire plant slows down. But when oxygen is abundant, they do the opposite. They accelerate, they produce more ATP, they divide more cells, they grow faster. A properly aerated hydroponic system can maintain that oxygen indefinitely. A deep water culture, for example, is a bucket of nutrient solution that has an air pump constantly pushing dissolved oxygen into that bucket. Meaning that if done well, hydroponics can significantly increase the amount of available oxygen. The truth is, hydroponics doesn't really make plants stronger, it just makes them stop struggling. And the third and final bottleneck that hydroponics really eliminates is the bottleneck of guesswork. It's control. Because in hydroponic gardens, you have insane control and flexibility and variation. And if you stay attuned to your plant and what it needs and what you could potentially do to optimize it in the hydroponic or aeroponic environment, then you yourself remove the bottleneck that exists with so many soil gardeners, and that is just control. But once you do learn these systems and how hydroponics works, how to maintain your EC and your pH, all of the variables, then you actually realize that it's a lot easier to have great results growing plants in hydroponics than it is in soil. Because once you learn, you control everything. And because you're controlling everything, you know what's going on, and the chances for something odd or unusual to happen are much less likely in a controlled hydroponic environment. I invite you to download all the free resources and watch all of my educational videos so that you can experience hydroponics for yourself. Let me know what you think in the comments below. I'm Chad from Humble Growth. Let's grow food, let's grow freedom, and let's grow smarter. See you in the next one.